and urban ecology, a project that we spent the last 9 years making. This is Noma. This is my houseboat, and this is basically the cleanest waste-to-energy power plant in the world. Denmark has become a little bit of a pioneer in the sense that only 4% of our waste goes into a landfill. 42% is recycled, and 54% is transformed into district heating and electricity. As a power source, 6 pounds of garbage from your kitchens turns into 4 hours of electricity and 5 hours of domestic heating. It's replacing the power plant in this photo right in the middle of Copenhagen. This is the opera. This is the Royal Theatre, right next to the marina. And it was clear when we did the competition 9 years ago that what was mesmerizing about this was this kind of marvel of modern engineering, that it was going to be the cleanest waste-to-energy power plant in the world. No toxins coming out of the chimney. So we thought maybe a mountain of trash could become an actual mountain. Our nearest ski slope in Copenhagen is 6 hours away in Isaberg in Sweden. We could put 2/3 of Isaberg's main slope on the roof of the power plant. And so we did. This is what it looked like this spring before opening. As you can see, there's still a little bit of vegetation missing. This is what it looked like in the winter. Of course, the kind of cliff face of the mountain is made out of these gigantic folded raw aluminum bricks that are actually planters. This spring, they're going to be full of green. Raw aluminum tilted so they actually reflect the surroundings, so that the building changes color over the course of the day. Inside the mountain, you have the entire administration overlooking the city, and then of course they look the city at the one side, and then they overview this marvel of modern engineering. It's also rather unusual because the entire power plant is actually daylit. 50% of the facade is transparent. So you have the administration inside, and of course you see the underside of the mountain that is above. The elevator ride up to the top of the ski hill is looking into this amazing space. This spring, it's going to open the tallest climbing wall in the world, 300 feet. I have no idea who's going to be climbing this thing. And of course, this kind of X-ray at night. And of course, like the fifth facade, in this case, the roof, is maybe the most exciting facade. It has skiing, and the skiing is for free. It's a public park. If you want to use the lift system, you have to buy a lift pass. It's sort of designed to be able to sort of help spread vegetation to the surrounding sort of post-industrial area. You have hiking paths, different kind of activity zones. You have a kind of vegetation that changes over the course of the season. There's more than 400 different trees, and in general, it's almost like Noma, that it's purely indigenous species. If Denmark had mountains, this is probably what they would look like. Also, the entire roof park has been made for a budget of around $13 million, which is absurdly inexpensive. So everything has really been done with the purpose of the least amount of maintenance and the least sort of acquisition cost. Maybe when I saw this photo, it dawned on me how insane it was that we were actually making a building with a ski lift on the roof. And maybe the most sort of important material, because Copenhagen doesn't have enough snow to be a serious ski destination. So we searched around and we found an Italian company that makes this kind of mat that has the same friction as a groomed slope. The only problem was that it was quite ugly. Also because because of the thermal expansion and contraction, it had to be split up in these, like, let's call it 7 by 7 foot squares. So we actually sat down together with the company, and in a course of a few months, we managed to develop an entire new product for them. And it's very simple. You have the old product on the left and our proposition on the right. Simply by joining every 2 circles in 2 different directions, the basic grid goes from squares to rectangles with 6 knots, which means that when they expand, they can become hexagons, and when they contract, they can become these kind of bow ties, which means that you can actually have one single continuous surface. So like this kind of very simple geometric invention that was then turned into the production, and now it's the standard product of the company, meant that we could actually have a continuous surface on the whole roof for the first time. We color coded it so that the brighter the slope is, the less likely you are to crash into the perimeter. And eventually the grass grows through because the grass is a major part of the structure that holds the mat to the roof. So eventually it's going to be like skiing on an alpine meadow. So here you see some of the first tests that we did. You can kind of hear and see that it has the feeling of a groomed slope, which also makes it kind of perfect for freestyle skiers, because you can actually do all of the grinds and the jumps and the tricks as you could on a normal slope. So I think what's amazing about this idea is that I think it kind of shows this kind of almost like world-changing power of architecture. That my son is 1 year old now, so he's never going to remember that there was a time when you couldn't ski on the power plant in Copenhagen. So for him and his entire generation, that's going to be their normal, and that's going to be the starting point from where they start having crazy ideas about their future. So that can almost make you angst about thinking about what kind of future they're going to come up with. So of course, like some kind of, I think also kind of a landmark for this kind of idea of hedonistic sustainability, that a sustainable city can also be not just better for the environment, but better for the people living there.